Most stars go out quietly. They expand, cool down, fade into white dwarfs, cosmic old age. But one star didn't. It died so violently, scientists say it broke the rules of space itself. Not a supernova, not a black hole. This was something else. Something that blasted a jet of energy so strong it shook the fabric of the universe. This is the story of a star that went out in the most extreme way we've ever seen. Most stars, like our sun, are cosmic homebodies. They burn hydrogen in their cores, quietly shining for billions of years without causing much trouble. They're stable, predictable, steady, but eventually the fuel runs out. And when that happens, they begin to swell, not explode, swell. They turn into red giants, bloated, cooler versions of themselves, and start gently shedding their outer layers into space. What's left behind is a white dwarf. No bigger than Earth, but with the mass of the sun. It just floats there, glowing dimly, fading away over trillions of years. No bang, no fire, no drama, just a soft, quiet exit. It's not flashy, but it's cosmic tradition. Most stars go out with grace, not with violence. But some stars are built different. When a star is massive, and I mean 8 times the mass of the sun or more, that same graceful ending, gone, not happening. These giants burn hotter and faster. They race through their fuel like they're on a countdown, and when the tank runs dry, gravity slams the core inward. The collapse is instant and brutal. The rebound? That's a supernova, a shockwave so powerful it outshines entire galaxies. We're talking about the birth of neutron stars, objects so dense you could fit a mountain into a teaspoon. Or, if the star's big enough, something even more extreme, a black hole. It's spectacular, it's devastating. But here's the thing, as massive and violent as these explosions are, they still follow the rules. Gravity, thermodynamics, radiation, all of it still within the playbook of physics. You see, most stars, even the dramatic ones, stay within the laws of physics. But one star didn't. It didn't just collapse, it didn't just explode. It detonated in a way that left scientists stunned. A burst of energy so concentrated, so violent, it seemed to violate everything we thought we knew. We're talking about a gamma ray burst, or GRB for short. And this one, it didn't just bend the rules. It took the rulebook, shredded it, and vaporized the pieces at nearly the speed of light. This wasn't just a star dying. This was a cosmic event so intense it fired 2 jets of energy so focused they could have wiped out life on any planet in their path, even from billions of light years away. This thing released more energy in 10 seconds than our sun will in its entire 10 billion year lifetime. Let that sink in. We don't even fully understand how it happened. And honestly, that's what makes it terrifying. In 2008, NASA's Fermi Space Telescope detected something absurd. A gamma ray burst, designated GRB 8916 CE. Catchy name, I know, but don't let the label fool you. This thing was a monster. It came from 12.2 billion light years away, which means it happened before Earth even existed, and we still felt it. In just 60 seconds, it released more energy than 9,000 supernova combined. That's not a typo. And the jets? They were moving at 99% the speed of light. Let me say that again. This thing was so fast, so powerful, some particles may have broken the Cherenkov limit, meaning they outran light through plasma. Not light in a vacuum, but still, that's next level physics. It pushed our understanding of energy release to the edge, and then laughed as it stepped over the edge. One scientist called it the most extreme stellar death ever observed. It wasn't just a star dying, it was the universe throwing a tantrum, a cosmic scream echoing across space-time, loud enough to be heard billions of years later. And the scariest part? We don't know exactly how it did it. Alright, so when we say this star broke the rules, we're not talking about a minor technical glitch. We mean it defied the limits of what our current physics says is even possible. Start with the energy. GRB 8916C released energy levels so extreme, they violated the Eddington limit, the threshold where radiation pressure should have blown the star apart before it could explode, but it didn't. Then there's the speed. Particles in the gamma ray jet may have exceeded the Cherenkov limit, basically moving faster than light in matter. Not in a vacuum, sure, but it still bent what we thought was unbendable. And let's talk time. The burst lasted over a minute, which is a lot when you're releasing 9,000 supernova worth of energy per second. It warped space-time around it, not just figuratively, but literally. Radiation from the burst traveled through interstellar plasma, distorting fields as it went. Some scientists believe quantum vacuum polarization may have kicked in, a fancy way of saying the very fabric of space may have briefly glitched, and we weren't even supposed to be able to see that much energy across that much distance. Yet we did. The models didn't predict this. The simulations didn't prepare us. It wasn't just off the charts, it shattered the charts, took the pieces and lit them on fire at relativistic speeds. This was a death so extreme it made the universe whisper back, "Wait, what?" So here's the terrifying question no one wants to ask. What if a gamma ray burst, like GRB 8916C, was aimed at us? Not from billions of light years away, but from within our own galaxy? Well, the truth is, we probably wouldn't see it coming. Gamma ray bursts are highly directional. They shoot out narrow, focused beams. If one of those beams hits Earth head-on, we don't get a second chance. There's no warning, no sirens, just flash. First the ozone layer, gone, shredded by intense gamma radiation in seconds. That means solar UV light pours in, damaging DNA, collapsing ecosystems, frying the surface of the planet. Next, atmospheric chemistry changes. The skies turn brownish from nitric oxide haze. Acid rain begins. Global temperatures drop. It's like a nuclear winter without the nukes. Mass extinctions? Yeah, we've had them. And some scientists think AGRB might have been the trigger for the Ordovician extinction, one of the big 5 die-offs in Earth's history. So yeah, it's rare, but if it ever did happen here, you'd never know what hit you. One second you're watching Cosmo Croc explain stars, the next second, so what kind of star causes this kind of galactic-level meltdown? Scientists believe the culprit was something called a Wolf-Rayet star. And if that name sounds cool, it is. These stars are massive, unstable, and dangerously short-tempered. A Wolf-Rayet star is like a ticking time bomb. It's lost its outer hydrogen layers, exposing its blazing hot core. It burns so hot, it's literally shedding itself into space at insane speeds. Some spin so fast, they distort into flattened, swirling disks of fusion and fury. But here's the kicker. When a Wolf-Rayet star dies, it doesn't just collapse. It funnels all that rotational energy and mass into 2 ultra-focused jets. That's your gamma ray burst. A jet so tight and powerful it could travel billions of light years and still have enough force to ruin your day. In the case of GRB 8960C, scientists think this star was probably 30 to 50 times the mass of our sun, rotating at insane speeds, with an iron core collapsing directly into a black hole. And for a few terrifying seconds, those twin beams of death screamed into the void. That star didn't just die, it went out like a cannon, firing a warning shot across the universe. We like to think we understand the universe, that we've got physics mostly figured out, but every now and then, a star explodes and reminds us we know nothing. Events like GRB 8916C aren't just rare, they're a warning shot from nature, telling us the cosmos still has cards up its sleeve. We're still finding new gamma ray bursts, catching stranger signals, detecting stranger light. Some bursts behave differently, some don't even fit our categories, and with telescopes like JWST and future deep space missions, we're peering deeper than ever before, further back in time, further into the unknown. Somewhere out there, another monster star is ticking, spinning, collapsing, waiting to fire its final breath across the galaxy. And when it does, we'll be watching. Because in a universe this wild, every star is a story, but some stories rewrite the laws we thought were unbreakable.